So this is the practical section of the IPC methods. So in this section we will study an example for every method that we described earlier in the previous section. So we will see a real coding implementation of the three methods. So the three methods that we had was shared method. So we had the shared method, we had the pipe method, and we also had the message passing method. So for every each of which we have a specific example. So let's go to the shared method, which was the first method. So for the shared method, we can the idea of shared method was to put a specific memory among the processes. So if you remember, that was the idea. So if I have P1 and P2, so let's call it more interestingly here. In this case, it's actually going to be, instead of P1 and P2, it's actually going to be the binary of reader and the binary of a writer. So this is actually going to be writer, and this is going to be a reader. So this is actually going to be reader, and this is actually going to be the writer. So this is going to create a, for example, data, and which actually is going to write information into a specific space, and then this will the read operation to get that information. So let's see how it works. So if I do write, so it is now waiting to put the data and write the data actually to the memory. So we are actually in this section. So we are in this part where we want to put the data to the memory. So let's put it into the memory. So I'm going to put like the string of something, and the data is well written into the memory, as you can see. So the data is actually being written now to the memory. So now what I'm going to do, I'm going to launch the binary of the reader, and the system and the binary of reader will be able to read the data. So now I'm going to read the binary of the reader, and it's exactly as it's supposed to be. So it could actually read a string from the space of this area. So that's actually something that happened. So when I launched the reader tried to read the data from this space and print it out as the string. So that's the whole idea of the first method, which actually you can actually put a specific amount of the data into a specific area of memory and read and write, do write operation. And as you can see that these are two completely independent processes, and so basically you perform an IPC here. So now let's go a little more in detail and see how the work works actually. So if I go to the reader code, I will find out that it's actually getting like that. So this is the reader, and at the right you have the writer. So I'm gonna actually open the write. So this is the writer and this is the reader. So the reader, what it tries to do, as it's obvious, is that it actually tries to it's actually quite very simple. So it's basically taking a shared memory ID for that specific key, and it will generate that key and generate shared memory ID, and then it tries to attach the string which is with the user program, which is actually with the reader, to the ID. So the shared memory attached is performing that attachment to that specific memory and tries to then print that string. And at the opposite side, we have also the same, so we need basically to generate the shared and to basically associate and attach the memory to the process, and then try to put the data into the string. So once we do it like that, then the string is going to be written into the system and the perform of operation will happen. And as you can see, there is one specific key so that actually identifies the memory which is allocated with this like functions which has generated the key of the memory, which is actually a unique. So this is the idea of the first method, which is shared memory. So now let's go to the second method, which is the pipe method. So if you remember, the pipe method was about the parent and the child. So we had a child and a parent process. So we had to establish a pipe. So we basically had to put a specific amount of a space. So we can actually put a pipe here to make the process parent to actually send the information to the child process. So what we need to do here, we need actually to do the write operation, and here we need actually to do the read operation. So the child process will read the data, and the parent process will write the data to the pipe, and then we can do this IPC operation. And then if you wanted to do and send the data back from the child to the parent, then we had to also establish another pipe which is going to do the same job, but at the opposite side. So we had to actually attach this end of the pipe to the write operation. So the child is going to actually do the write operation, and in this end is going to do the read operation for the parent process. So let's examine that and see what's going to happen. So I'm going to write just actually the mom pipe, which is like at the beginning of the program, which is actually here. So the child process is not initially generated. So once when I launch the my pipe binary, this is actually going to create two processes, and one which is actually P and another is C, that actually at the same time there are going to have two processes, one parent and another child, and then perform the IPC operation inside the program. So I'm going to launch the program, and you will see that it is actually waiting for the data to put here in the input of the first pipe. So I am going to write like my string. Okay, good. So what has happened here is that the parent process, as you can see, tried to write the my string that I put for this into the pipe, and then the child responds with the my string plus another string which is called concatenation, which is kind of probably a string related to the child process added to the my string that I put. So I put the my string here,